What's up, everybody? This is page 396. Thank you for checking in. We are going to finish out this lesson and move one step closer to, well, finishing out this textbook, but also kind of wrapping up a concept. We've been talking about hypotenuse, triangle, leg angle relationships that prove that triangles are congruent. So I have this card, hypotenuse leg triangle congruence theorem. It was made with notes from page 389. Of course, at any time along the way, stop the video and copy down what you're missing. We have the leg angle triangle congruence theorem, the LA, and it was made with notes from page 380, so please feel free to capture what's there. See, there's the whole card. We have this one. We have leg triangle congruence theorem, and this one was from page 390, the notes that are there. And then the last one actually coming in from a previous topic, hypotenuse angle congruence theorem, and didn't catch the page number yet, but I know that I can go look at the glossary, index, etc., and the information in the back of the book and find it. Let's use those four cards in order to help answer the questions that are on page 396. One of the things that's there, I'm going to suggest that you have 4 highlighters and that you have some extra colors that you're going to be drawing with, not just your standard pencil. Please do this in color. All right, you have many different theorems, there they are, that prove two triangles are congruent depending on what you know. So let's consider how the triangle, the right triangle, that's a highlighted word right there. We're only focusing on right triangles. How the right triangle congruence theorems are related to the triangle congruence theorems associated with all triangles. List the 4. So we have HA, and we have LL, and we have LA, and we have HL. Those are the 4 right triangle congruence theorems. Technically, they all have a third criteria. They all have 90 degrees, 90 degrees, and a 90-degree angle. So they have an A here that is a 90 degrees. And that's really what makes this work. If it didn't have a 90-degree triangle, a 90-degree angle in the right triangle, it wouldn't be a right triangle, and therefore these 4 things wouldn't work. We'd have to rely on the other 4 triangle congruence theorems, like side, 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 and side, and angle, side, angle, and angle, angle. Oops, I almost wrote another angle. Angle, angle, side. You know what's not used? SSA. And I don't want to write it the other way around. You know why. Your brain is working, so that'll actually not work. However, any of these that do work, they're kind of like SSA. That's all I'm going to say about that. Okay, let's finish the last question here, and then this page is done. Associate each theorem in question 1 with one or more of the related theorems in question 2. So in order to do that, let's go ahead and acknowledge that you need to actually sketch out and do it nice. Draw them out with, like measuring them. I measured so that all of my sides, I made all of these triangles look congruent. Pause the video here, sketch out your 10 triangles, sketch it out with this framework here, and then come back and resume the video when you're done. I'll wait. Only long enough to presume that you paused it. So let's get into it. Now you're back, and we're going to keep going. Thank you for unpausing and keeping going if you're following along. I'm going to use my highlight colors, and I'm going to specifically highlight all of my hypotenuses. I think I've been using green. So I'm going to highlight, for HL, I'm going to highlight the hypotenuses green. And for HA, I'm going to highlight the hypotenuses green. And for LL, I'm going to highlight the hypotenuses green. But I'm going to leave LA alone because specifically leg angle, I'm not focusing on the hypotenuse. Like I know it's there, but I don't need to mention it or reference it. For HL, we do have a right angle, but I'm going to say that this is the side that we have to look for. We look for the hypotenuse and a leg that match a hypotenuse and leg in the other right triangle. Wait, how do you know that they're a right triangle? They're missing the boxes. You got to look for the box that signifies that you have a right angle. And so that is the goal right here, so identify that. Now, leg angle. I'm going to highlight a leg. I'm going to highlight an angle. I think I'm going to highlight this angle. I mean, it could switch. That is why there's 2 comparisons. Maybe I don't highlight the angle here. Actually, I'm going to keep highlighting the same spot. There's no numbers attached to this, so you could feasibly like rotate this into any position. You can rotate it to the vertical up here, or you could continue using the angle on the right side, or maybe the triangle has been flipped, so now it's on the left side instead of where it was before. The leg that we're talking about, it could be the leg that is between the right angle and the angle that we've drawn. So that leg is between two angles. This would technically be an angle-side angle relationship, but LA does the job. Over here, the leg I'm going to highlight, bring in a different color for a different line that I'm highlighting. Maybe the leg is not between the two angles, and so this would actually still be congruent by LA, but it's actually because of angle, angle, side. Literally, the S side is not written between the two A angles. Over here, hypotenuse leg usually is proved with side, 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 because if you know two sides of a right triangle, a little a squared plus b squared equals c squared action helps you find the third side. So we actually do know all three sides, given that you know two of them along the way. That is a side, side, side relationship. Okay, now we're up with hypotenuse angle, and the only thing that we really know is the hypotenuse, and maybe it's the angle that is created, it could be that we flip it around. I'm always going to highlight the same spot, but we could have turned the triangles to a different location or drawn them with a bigger angle, but kept the 90, so that yellow might be in a different spot. But it still is creating two congruent triangles because of hypotenuse angle, and if you look, it's angle, angle, side is why this one works. Angle, angle, side. All right, the last one, leg, leg. So we know that these two legs match, and we know that these two legs, see the switch in the color? That those two legs match. And so if you know that two legs, you already know the two legs of the right triangle, you can just use Pythagorean theorem to find the third, and so therefore by side, 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 those are also meant to be congruent. I guess technically the only one of these that could be SAS. Oh, this one could be SAS, right? Maybe you don't need to use Pythagorean theorem, although it works. But maybe you don't use Pythagorean theorem. You just need to show the triangles are congruent. So you say, hey, we got right angles. Hey, we got sides that are corresponding and matched. So therefore, side, angle, side. This might actually be a faster reason to show why those triangles match. That is it for this video. Thank you so much for watching. Thanks for watching this lesson and completing your journey along the way. Lesson 2 is next, and a little heads up, lesson 2 is going to talk about, checking it out right now, quadrilaterals, things that we can do inside quadrilaterals, those properties of quadrilaterals, and it'll be more or less a repeat with some extra meat, some extra information from what we did in the previous 2 topics. So thank you for sticking around and watching this video. Go ahead and click forward. The next video will begin on page 399, and I'll see you there. Like, comment, and subscribe.